welcome back to my channel. This is the second session of SQL Server online database training, and we're gonna cover in this session the structuring of relational database. Then we will talk about the size, the growth parameter, and the database schema. Then we will move to the definition of tables. We will talk about the indexing, adding, modifying, and deleting the columns. And then we will talk about the relation between these two tables, how we are creating the primary key, what is the use, and how it is related to the other table. And then we will talk about the check constraints as well. So this gonna be a longer session, so without wasting time, let's dive in and quick start our session. Database is a collection of certain files. Number one is system file. System file are the file for Windows, including your page file as well as the SQL Server binary file. And then move to your data files, which is the .mdf and .ndf are the files where SQL store all of your database data and schema information. And then the most important is transaction log file. Every SQL server, we have to understand, database has a transaction log that records all transaction in the database modification made by each transaction. The transaction log is critical components of the database. We have to understand this first. If there is a system failure, you will need that log to bring your database back in the system. So the warning is never delete or move this log unless you fully understand the circumstances. So these files are very important while running your database. Let's move to the designing part of the system and recommendation from the SQL for the SQL server. The number one is file size. When creating your database, you will need space to your database files, right? You should make the file large enough to contain the initial amount of data you expect, plus allow for some file growth is very important. Configuring your database file to grow automatically. Fix disk space amount. This will allow your database to grow over time. However, ensure your database does not need to grow more than once a week. Very important. If that happens, then increase the size of the grow amount. Unless you know you will be loading more data, make your data file size 2 GB and set the transaction log file just half, which is 512 MB. So both files should be set auto grow by 512 MB if you are picking up 2 GB. So this is similarly, if you are growing, if you are planning for 8 GB data file with a larger one, considering splitting the data between 8 GB data file this is most important. The more you are growing, but the more you are occupying space, you need to split the data in order to run the smooth database and the queries. Your file space, since each set of files has different I/O needs, it's best to place them on separate volumes that have been designed to provide the necessary performance. This is what I was talking about if we are choosing the 8 GB and up. So even if your server is already built, make sure you understand the need of each file set and use that to optimize your current installation. In particular, separating your log files and data files over different physical operating system subsystem will usually result in big performance again. So defragmentation. So database files should be placed on volumes with large chunk of free space to minimize file fragmentation. Normal database use will result in file growth, which may lead to further file fragmentation. You should schedule defragmentation tasks to be run on a regular basis so fragmentation is kept in minimum, which is important. These are all file database maintenance without interfering of database engineer. Then we have to move to the maintenance part of the SQL Server. Some recommendations are: you should correctly configure maintenance plans, will help your database maintain its peak performance level while allowing you to have regular backup of your data. So integrating checks should be done at least on a weekly basis before a full backup is executed. So this will prevent backup from occurring after database corruption as has occurred and will prompt for DBA intervention. So as indexes grow, they will become fragmented. So configuring index reorganization will make SQL Server reorganize those indexes. So this process makes low usage of system resources and can be used with the index online, allow selects to be executed. So, however, if your index are highly fragmented, you will achieve better results by rebuilding the index. Very important, very important point to be noted. So, otherwise, index or reorganization should be evaluated by the DBA only. So this is the portion where DBA will be interrupted and jump. So index rebuilding makes SQL Server drop the existing index, reclaim resources used by the index, and then recreate the index in contiguous pages. This is a more resource intensive operation that achieves a smaller or similar results to index reorganization. So SQL Server query govern uses table and index statistics. So it is which indexes are better suitable to each query. If your statistic become out of date, better indexes that would yield faster query times may not be used. So depending on how often your data changes, you should rebuild the statistics with your maintenance plan. Typical values are daily for systems where there are significant changes to table contains each day to weekly if your data is mostly constant. And in that reasons, because the databases keep on growing and maintenance is required, the most important thing is you have to take a backup each day, each time, depending on usage of your database, which is very important. So you need a backup, regular backup. Then you have the data shrink, which is very important. When you are growing, you have some data shrink is required, which is through the database engineer need to be done, and that will release some disk space for you in future to store more data and giving you more space and cleaning the data. So these are the basics maintenance plans you need to create even if you are running your SQL Server on your system. you required your database to be moved in this. So the database schema is a collection of logical connected database objects and elements such as table, storage, procedure, views, function, and trigger, and so on. So let's see here. I just wanted to show you the structure I have created. This is the database, and you can see the schema has been created with the three tables, and the table is consist of storage, functions, views, and table, and so on. And see it's here the how the server is established. We have a instance, SQL instance, and within the instance we have a database, one database, and within the database we have multiple schemas. So schemas can, n number of schemas can be there in one database. So like here is the schema 1, where is table 1 and table 2, and we can create number of tables. Then schema HR, when we have I'm sorry, we have table 1 and table 2, which is employee and address, and then I have another schema person, then we have department and salary. So the collection of schemas are become one database, and that is stored into the instances. So in the instance, you can see how the structuring is created when we are considering a database. Let's move to the SQL Server. This is the SQL Server, and I have created, I just want to show you how the database is created. The SQL Server have two different ways. You can use your scripts, or you can use the wizard. So I will show you how you are gonna create this script. This is the recommendation from me and from most of the consultants, because this is the most accurate way to go, where you can create your script with the appropriate addresses, size, and the file growth, and so on. I will show you how you can create using your wizard as well. So let's move. So what I did is I used the command, which is create database, and then I gave my name, database name. You can give any name, whatever you want, and then you need to provide, I'm sorry, you need to provide the dat file, which is the MDF file that it is needed, and you need to provide the parameter for that, and then you need to provide the log file details as well. So creating your database with the MDF file and with the log file, which is transaction file. So I'm naming the mydb underscore dat, and then I'm giving the file location, which is with the name which you wanted to give to your dat file. So mydb, I should give the space so that it will be this. So I'm gonna show you where it is. So this is the location where your all the database is stored, and you need to provide this location, which is under the file and micro SQL server, and this is the location. So I got this location from here, and I'm giving the name of the file that once it create these two files and store it into this location. So the size is, I'm going in only very small size, which is 10 MB, and then maximum size 50, and growth is 5. So you remember I told your growth should be, it should be half of your size. So here also your growth should be half of your size or equal to your size. So this is your log file gonna be reside on the same location with the new name what you want to give, and then you need to provide the size, the maximum size, and file growth. Once you created everything, you need to run the command and it will give you the command successfully completed. Now refresh your database and you can see my DB has been created. Let's move to the property, and the property of this is gonna show you that what we have done here. So in general, it is showing the owner is a default owner, and because we are on a initial stage, so we are not providing the owner here, otherwise we need to expand the parameters and we define so many things there. But because it's a basics, the beginning of the database, how you can create a basic database, for that this is the parameter and this is the scripts for you. Then your size and your spaces, and you can see number of users, because number of users I have created, it's giving the default user. It depends how many users you grant. So the grant permissions will be your next session, when you will granting or giving permission to the user, revoking the permissions from the user. So now come to the files section, and in the file section you can see whatever we have done here in this area, it is showing here. Now see, the location is this, my dbdeck.mdv and the log.ldf, and then see the size is 10 and the 5, and the name what we have given here is the name of the file. Now see the auto growth max size, you have dots, just click those and then see you will find the properties of this size growth. So you always need to be enable auto growth. It is advisable you need to keep your data on auto growth, and it should be, the file growth should not be in percentage, it should be in bytes, because percentage is allocating more space and bytes are allocating space whatever you are depending on your database. So it grow according to your database, and percentage is fixed percentage. So for that reason you need to choose the uh, the uh, the megabytes. But in some scenarios you definitely need to use the percentage as well, but that is gonna be a bigger side when we are talking about the server, different database, storage, and so on. The maximum size is 50 we have given, and you can give the unlimited, but minimum, but we need to provide the limited size so that we will have opportunity to grow as much as we can. And then the same way you can go into the log file and you need to provide the same parameters and make it enable auto growth and say okay. So this is the SQL Server file database property, which is being auto created and established when you have created your database. So there are some enabled or disabled properties options for you to change if you want. So it gonna depend on your how you wanna move, like shrinks, you wanted to apply shrinks or you don't want to apply shrinks. So if you wanted to apply auto shrink, you need to say yes, then it will do automatically. Mostly DBAs are doing this because they need to do the analysis and then they run the shrink. So default we don't need to do this auto shrink. So but here are the option for you. The highlighted one is can be changed as per your requirement if you needed to do so. So this is the overall file creation, database creation. Let's move how you can run the wizard. It's very easy in this scenario. Just right click the database and you say new database. And then when you are running, saying database, the new pop-up window will be there. And you are gonna see the system has already created or occupy a space for you for your log file or for your data file. So my next DB. So see the name what I have provided is extended here. Same name is copied here because it is gonna be see, you can see the mydb log file, mydb data file and log file has been created. Similarly, the one which we are going to create now, it's gonna be created and gonna be stored here. And then you can see that initial size is 8 by default. You can give 15, and this is 7, always half of your or db size. And then go to your growth size, make sure the auto growth is enabled and megabyte is 64 it's given. You can change it to the we are here in the DB, so it should be 15. So we can say it should be auto growth should be like we have done in the so let's say for example it should be 7 and limited is that's 30. Okay, and then move to your log file. There you can say that it should be 2 and it should be 30 maximum. Now you come to the default, the owner. So you can change the owner here if you want. So it is not defined, so no way you are using the default owner, which is only the one owner. Now you can move to the options before hitting the OK button, and you make sure that you have checked everything depending on your requirement. And the file groups are the primary groups, and these are the default. We don't need to do anything. And then just we need to move to the OK. But before moving, I can give you one thing, that you can add more files as much as you want. Like say for example you wanted to add more primary file and you wanted to set by yourself, so you can do it. Otherwise you can run the default one to basics files. So this is gonna be a very advanced level. We may come back later on, but this is the initial stage for the intermediate and beginner, or even the advanced, because we are also using the same way, and then we are coming back if we needed more files, we can do the extensions. So you can see that the new database has been created for us. So for today we have created 2 databases, and in these databases you can find out that how we have created, and how it's gonna it be changed, and how we have established the structuring of the database. So the next is defining data type in tables. So SQL data types are various, but mainly what we are using is in front of you. So a data type, let's understand what is data type. A data type defines the type of data in a table, column, or variable. It is mandatory and essential step in designing a table. A table with inappropriate data type can lead to various issues such as improper query optimization, performances issues, and data truncation, and so on. So defining table is very important to focus on what we are picking up as a data type and what is the use. So analysis is very important before beginning or starting creating table. So number one is, here is numeric. So the new in the numeric we have mainly integer and float. There are many others, but integer, float we are using. So integer is like 1 2 3 4 5 6, whatever number you wanted to enter, 1 to 10. And then float, 1 to 9. So and the float is decimal, so like 12.3, 45.8, something like. So decimal is required. It is good for the currency type or something. We are using currencies also, but floating, sometimes we are using decimal into the calculation as well. Let's understand the internally what these SQL accepting internally. So integer is 4 bytes character. It's accepting 4 byte. Float it is accepting 4 bytes, and it is up to 124 comma 7 character it, it can accept. Now come to the character string. The character string is the char is uses the maximum 8000 byte as a size, and varchar is also using 8 byte as a size. But there is a difference between the varchar and char. The char is the using the fixed number or fixed byte, and the varchar is using the vast, n number of length. So the difference in this is that the char is using fixed size and the varchar is using variable length, where the as you can see that it though both are accepting 1 to 8000 bytes. So char is fixed amount storage based on size of the column, where the varchar uses varying amount of storage space based on the size of the string store. So even though the char has a better performance and the varchar has slightly poor performance because the length has to be accounted for. So if you confuse what is varchar and char, just need to understand that char is taking fixed number of character. It is used for the fixed number. Let's say, for example, if you are using the country code like US or UK or somewhat, it is better to use char. So the varchar it is can store characters, number, special character, just like char column, and can support a string up to 8000 in size. A variable length column only takes up to space it needs to store string of character. So that is the difference between the char and varchar. Now move to the next, which is the Unicode char string, which is the nchar or nnext. Nchar is using up to 4,000, storing up to 4,000 Unicode. So in Unicode, in the sense that n char within the bracket you can give numbers. So Unicode numbers it is accepting, and then n text is Unicode characters they are accepting. Say for example, I'm just taking you to the query, and we'll show you like select and char, and if I'm saying 56, so it is showing you 65, it is showing A. 55, it will show you the 7. So the nchar numbers has been defined as a number or as a character. The only thing you need to provide the value here. So now next is the binary. So we are using binary and image. So binary and images are two different portions, areas uh, where we are talking about the images and the file. So the binary format it takes into the binary because the images and the files are huge. So always we are preferring we wanted to provide a data type which is accepting the images and file. So binary is the best fit for storing the these images and the files. Same the images section. So the images is used through the blob, which is the binary large object. So whenever you are trying to store the image, you need to use blob. So we will come back when we gonna explore all these data types in the coming sessions, and I will give you in detail with practical. Now come to the date and time. So the date and time, definitely it is started. The default is YYY MMDT. So YY is year, MM is month, and DD is date. Similarly, if we are using date and time, so we use date time where YY, MM, DD, and then hours, HH, minutes, MI, and SS is seconds. So this is the data type format, date and time. Now come to the miscellaneous. So the miscellaneous is XML and JSON. So XML definitely we should have provision to, because now we are using XML frequently in the websites, and also if we need to store the XML coding, that can be possible using XML data type. This is the built-in like integer and varchar, but it is I mean it's a built-in, but it can accept it has to use the XML type, and it is using the conversions also. So you need to convert sometimes we need to convert, so you need to use the conversions as well to use these languages. Now the JSON is the JavaScript object notation, and that exchange data in modern web and mobile. So this is also it introduced in 2016 30.x SQL Server version. So JSON is popular textual data format that's used for exchanging data in modern web and mobile application. So the JSON is also used for storing unstructured data in log file or NoSQL database such as Microsoft Azure, Cosmos DB, and many REST services in return. So it's being used, and it can be utilized when we are talking about the JavaScript object notation, when we are exchanging between the web and mobile. So it's a little bit different and vast topic, and we will come back later on. So here are the fewer or most important data type when we are creating the table. Here I give you some examples how the tables are created, what is the queries, or uh, uh, what is the structure. So the structure is the first one. We are utilizing the create table, and then we should have after the create table we need to provide the different parameters and the data types. See here, the data types has been defined. So now let's move to the SQL Server, and I will show you how the database has been created, how it being worked. So as I told you, always you need to start with a script. You can go directly any database and you can right click and say new and table, but this is the right practice. If you are using these scripts, this will give you the space to think or to do the correction before moving. So now as you remember in the initial um, I mean, in this session, in the beginning, we were talking about the database, how we created. So we created MyDB, and within the MyDB, I'm gonna create these tables. So this is the table which author and books I have created, and in this I will let you know. I will discuss about the relationship as well. So the relational table, if we are going to create, definitely we should have minimum two tables to create relational table. First of all, you need to select the data type, which database you wanted to store these tables. So I'm using MyDB, and now I said create table, author ID. I need to define the data types. So the first is author ID. Author ID should be numeric, and it should be primary key. So I defined the primary key. I will come back later on what is that, but in overall this is the ID. Author ID is primary key because it required the relationship with to establish with other table, and it required unique data. For that reason we have established primary key. Now we have author name. I use varchar data type, and which is 20. You can maximize 40. Author name can be 40, or you can say 100 also. Sometimes it is more than 100 characters. So then we have book ID, which is integer type and not null. So I said not null means it cannot be null. We need to provide some data in it when we are inserting the data. Now select this and say run. So you can see the complete successfully. It says complete successfully. Now you can refresh and go to the table and section, and you will see the author has been created. Now we have another table which is books. The books ID is primary because ID should be unique and it should be linked. And then book title is 50. You can take 100 up to. The price is float. As I discussed you, floating is just decimal, so we can use the concurrency. And publish is bit. Bit is single bit, 1 bit we can use. Now come to to the next table, which is, let's create this. I created this one, and then refresh it, and then you can see the two tables has been created. So now we have another table, which is author books. This author is actually have the references and then table. So let's move. So author ID is integer type, and it has foreign key references, and this is I think we will come back just a little bit later. Let me complete the table creation with the data type. So this is author ID. Then I take author ID. Remember, I took the upper, so I need to take the same because I need to give the reference. So I need to take the same integer type, same data type, and same name into there. So, and not null because it's a primary, so we can say not null. It should not be null. Now book ID I have taken from here, primary key, so reference will be book ID. It should be integer, same, because it's a primary, it should not be null. Now these are the table is special. When I will create once, I will let you know what is the foreign key, how the relationship is established, because this table is creating the relationship between these two. Let's move back to the next phase, which is the protecting data constraints. So now we will talk about the relationship applying uniqueness via primary key constraints. What are primary key? So when you heard about the child and parent relationship, we all have child and parent relationship. Childs are the references of the parents. Childs are dependent on parents. So see here, this is the parent and this is the child. This is the primary key, where in the primary key we have the unique constraints or unique indexing. That means if we enter the data, we should enter unique data. If we say 1 2 in one row, we cannot use 1 2 in another row. That is the basic criteria of this parent, and we should use the primary key into the column. Now come to the child. Child is the foreign key. It should use the foreign key as a variable, and indexing is optional. That means it can be indexed, it can be optional, but because it's a reference, so it will take the reference from the parents. So whatever data has been available in parent table, it should take for the same data in the child. So at that way it created the references. Let's say here is the example. We have this the order table and order item table. So the ID is order table ID, means order ID. So one is ID of this order, and when we come order item, we are taking the order ID, same order ID it here. We can use 1 many time, and we can use 2 many time, 3 many time, 4 many time, and even 5 many time. But because 6 is not into order table, ID is not available, we cannot use 6 here. It will always give you error if this ID is referencing this column. So that's the relationship. This is the reference. That's why it's a parent and child relationship, it says. Now come here, how the primary key is related or creating the relationship between the tables. We have order, we have order item, product, supplier, and customer. So the order ID is related to here, referencing this order ID in the order item. The order number is referencing the customer ID. Sorry, the customer ID is referencing here. Actually, it should be here. With this. So the customer ID is referencing the ID. That way it is related. Then uh, the supplier ID is referencing the ID is referencing the supplier ID. That way it is connected. So you can see how the relationship is established, and in this way, directly or indirectly, all the tables are connected with each other. These two tables are not connected directly, but you can see it is connected to the first table and it is connected to the last table. So the first table is connected here, and then this order is connected to the item. In this way it is related, and then order item is connected to the product. So see how the relationship is established directly or indirectly using the references. So the condition is there should be not null, no duplicate values should be here. So let's move back and see uh, what I was talking here with this. So to establish the relationship, we should have primary key. So I already gave a primary key to this uh, author ID and book ID. Now we need to establish the references because it's the child table and it has the child key. So to establish the child or foreign key, what we need is, first criteria is the name of the column should be similar or same as the primary key, and the data type should be same. It should not be null because it's a primary. Now we need to give the foreign key, and then we say references. So the references, we need to define where it is referencing. So we need to define DBO dot author is a table name, and bracket within the author we have author ID column that need to be referencing. Similarly, in the book ID is referencing using foreign key references DBO books book ID. So it is directly related to the referencing to these two tables. Now that's how it is created. Now I wanted to go back again and I wanted to explain you what is exactly this is. So now you understand how parent and child are related. We have another situation which is, say, composite primary key. Composite primary key means that a primary key can number of. This is true that a primary key can have number of primary key in one table, and then primary key can have composite primary keys as well. Primary key composite means that one primary key can have not only one but 2, 3 or 4 columns together. See, this is one column related to another column. This is one. But if I'm saying that I wanted to create a primary key with with this column, and this column, then it is possible. So composite is the combination of multiple columns in one primary key. Now this is how it is established. Let's go back to the same table, and what I'm doing is I'm saying that the author book should have a primary key with the author ID and book ID. So that, why I'm doing this, so whenever the author books data entry or author is required, I mean books, author books is required, the primary key should be triggered when the author ID and book ID is the same. Means that author ID should be equal, same. I mean, it is mentioned into the author, and book ID should be same. So these two combination together become the composite that can be possible. So here I use the constraint. Constraints are nothing, is a syntax to name a constraint, make it easier to drop the table using the name you have chosen. So it is very easy when you create, when you naming constraint pk book author, so you understand it is the primary key, pk is primary key, and the table is book author. So whenever you're trying to drop, if you are giving this name, you understand, anyone can understand this is the primary key and the table is author. Then you need to provide the primary key notation or the value, and then the value of the primary key. So because see here the primary key is for 1, so now here I'm defining 2 columns together into 1 primary key. So that is called the composite uh, primary key. Now let's create the database. Sorry, table has created, and then we say refresh, and in the table you can see that all the 3 are created. So if you go to the keys, the pk author is created for this. If you go to the author and keys, you will see 3 are created. What is 3? What are 3? 3 is the foreign key and the primary key of this only. So it means that when we are entering data, we are entering in this the author key and the book ID are together with the same values. We should be, I will let you know how it is working. So you can see that 3 has been created. So you can see the primary key icon and the referencing icon is what. Now come to the book, and book also establish the same thing, and come to the columns. So the columns are created. So each and every table has the columns. See, the 2 columns are here. It's showing pk and fk, integer not or allowed. So if you double click, you will go to, it will take you to another window, and it will show you the 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 properties of uh, this column, of this tables column. So in this way, we are creating the database and the table, and we are establishing the relationship, and this is called the relational database or relational tables. I was talking about that how we can create multiple keys into one table. It is possible we can do that. Let's say, for example, go back, we have the table, and just do not consider this, that I have a table and in author, and I want to make the author as a primary key and the book ID also as a primary key, because we don't have this table. We can do that. We can create multiple primary keys, but it should be a logically built and structured. We just cannot do like that. But the better thing is that you have to create different, because see, it's making sense. The author is talking about the author, but the book ID is mentioned to create the relation here. So the books is giving you the entire book ID, and the entire reference of the price, publish, and so on. And the book author books is the referencing of these two and creating the constraints. Now insert the database. So when we say inserting the data, we are saying insert into table, name, and values. So we are inserting value because the author, so first value is, let's go back to the author. So see the column. So the first column is author, author name, and book ID. So the author ID is primary key. So be careful, we cannot repeat. So move the author ID and book name and the book ID. What is book ID? So let's create one. One row has created. Let's go similarly, go to second row, go to third row. I already done this exercise, so you can see. I wanted to take you the another. What happen if I'm trying to insert again the same? What is this? It is giving you the error. Wow. And it's showing you violation of primary key constraint. PK author, this one cannot be, see, 7058B. Okay, so this is violating, cannot insert duplicate key in object author. The duplicate key value is 12. See how we are trapping, and this is your next move, that how to protect data with constraint, how to check the constraint. This is the way you are checking the check constraints are the rule or set of rules that have checked the inserted or updated data value into your table, so that it can violate, it can provide the necessary objection that you are doing wrong. For that reason, we are doing this relationship, working on the relationship, creating the relations, creating the references, creating the constraints, so that we understand immediately what this error is talking about. So we cannot do that now. So the duplicate is not permissible because the 12 is already entered. Now come back to the book. We have to enter the data. Boom. So 1, 2, 3, all data has been entered. You can select all and run simultaneously. What has happened? So the book ID, price, and this. So the book ID is the same. Can we do that? Can we repeat it? It will violate. It will violate because of this key. See the key 101 is violating. That means duplicate value cannot be inserted. This is the check constraint. So now come to the insert this. What I'm doing here, I am author book, and you can use the see, this is you can only use these values and these values. See how it is this. So this is the value I have created. Now go back and say 16. Can we insert it? It will give you this error. What is this error? This is the key B99, foreign key, author. It is saying author ID. Author ID is wrong because there is no author. 16 author ID is not available, so it's not gonna work. So it will not accept it. It can accept this because 102 is available in the book ID, but the uh, author ID is not available. So if we say 50 and we are saying that author ID is 222, is it gonna work? It is not gonna. Now it's saying book ID, so this one is violated. See how it is beautifully, it is working, how beautifully it is doing the it is generating. So see the 12, 1201, 15, 0, 15, 104, the way it is. So now remember the primary key is author and this. So these are the combinations are created in this table. So when we are taking the references of this as a primary, this is the primary, and we are taking references of another table, from the table. So we have to make mind that these references are there in the another table. So that is the best practice we are doing in this. That's how we are creating the relationship, and that's how we have established the child and parent relationship using references, and how multiple tables are interlinked or connected directly or indirectly with each other. And that's how we can establish the relational database into the SQL Server. So the next small session or next topic is indexing table, which is very important. When you establish the indexing, that is mean a lot to the performance of the table, the durability of the table, and so on. When you do the query, you will be noticing that it is fasting your queries and all. So indexing allow queries to run faster for data selection and are a key part of high performance for SQL Server. So the number of indexing are cluster indexing, physically sort the data page by a column or column that are part of the clustered index. So the cluster index can be created on one or multiple columns, and you can have only one cluster index per table. It depends how you can do it. So the next is the non-clustering. So the non-clustering is index pages are sorted by the index, but that doesn't affect the actual data. This is the main difference when compared to clustering index. So a non-cluster index does not touch the actual data page except for pointers that point to the data page. So that's the difference between the cluster and non-cluster database. So come to the filter indexing. So the filter indexing is always um, a very useful feature of SQL Server, which can have a possible positive impact on query performance. By using filter criteria, we can make sure the query uses a subset of the full data, full table based on the filter settings. The results in efficient index performances and faster extract of result. And then the altering and dropping indexing. So we can alter, we can drop indexes whenever we wanted. It doesn't require much effort. It just in SQL Server just need to go back, and then you need to establish the connection and so on. Let's go back. And let's say, for example, you are in this table, and you are saying index. See, the indexing is here. So you can right click and say new index. When you go, you will see no cluster indexing is not available, and non-cluster indexes are available. And you can see, as I told you, why the physical sort of the data page by a column and column, and this is non-clusters are sorted by the index. So for that reason, we have this non-cluster. So let's go to the non-cluster, and then when you come to the uh, non-cluster indexing, it is showing the new indexing. So it is by default, everything is available. The only thing you need to do is to add here the index key column. So how you can do that? You just need to go to the add, and then it will give you the name of the columns of these tables, because we are in the author table. So the author ID and name is there. Author ID or the book ID is there, because these are the keys, and these are the key primary keys and the foreign keys, and that's why, and these are the that's why they are included in the indexing. So we if I say the indexing author, and at the same time I'm saying books also, so you just select it, and then you set this, you boom that. So see, it's here, so you don't need to do nothing, it is available for you. Then if you wanted to go to optional side, it is by default, but you can provide the details as you want, like sort in tempdb. Like tempdb is when you are in the transaction, so the data will be sorted into tempdb as was, so it will not filter, or it will not sorted. So on the storage, you can see you can provide the partial schema. I was talking about the schema, and then in the schema I said to you, you can use the partial schema as well. Partial in the sense that you should divide or transfer your, you should divide your data or your schema when you are going beyond 8 GB. So that's the area. And then filter is there, and extended properties. So we are not discussing this in this point, so we're just adding, and then we are just including columns. If you are saying, so you can use the columns as well, but we are not doing this, we are doing indexing key columns only. So the key columns is this. If you want, you can remove that one. We can use the indexing for this. That will be the for fastest performance, because of the primary key, and indexing is establishing. So indexing has been created, and refresh it, and you will see the non-cluster is there. Because see, as I told you, that why it is not showing, the reason is primary key already created the cluster, so we don't need to create the indexing. So come here, so you can see the primary key is already created, but if you wanted to do the clustering indexing for this, so non-indexing is available for you, and you just go there, and you says that I wanna author name indexing, and then say boom, and then you will see the indexing non-cluster indexing is created. That's how you can you can establish the indexing into the table. It is very useful when you are doing the heavy queries like this heavy query. So for this query, you definitely need indexing. It should not stack when you have heavy data. You have thousands or too much of data available and you are extracting much data into it. So in that case, it required indexing for that. So indexing definitely is providing the number of benefits for you. The only thing is how you are establishing into this. Now come to the alter. This is the last portion, which is the defining table, adding, more modifying and removing columns. So can we do that? Yes, definitely we can do that, but the only the syntax is alter table. Alter, in add case you need to add, in modify case you need to modify, in drop case you need to drop. So see, I have created the top table name. So let's go alter author. Make sure you are in DBs, then only this query will work. Otherwise, you need to define the database as well. So alter author table name, and then add author. See what you can add in the column. So author ID, author name, book ID, year, the year as Nancy. You can say 10 character, or you don't need to define this. It all already take, but if you are defining is okay. Say alter the it is defined. So see, it is defined. So now if you go and say yes, and then column. So same way, if we wanted to modify, so we need to use the alter table books, and then alter column and column name and the variable. Let's say for example, if we wanted to say that price should be or publish should not null, so we column published is not null, so we can say not null. So in this way, if we run it, published it not null, so it will execute. So now let's say refresh, and then in refresh you see it's showing not null. So in this way you can do the alteration. Now if you wanted to drop, let's say for example we created these two and we wanted to drop, so we say go to the alter table table name, and then we are saying drop column is P year, and then execute it done. So this is the end of this session. We have learned in this session about the relational database, defining table, defining relations between two tables, and primary key, foreign key, and constraints as well. We learned the requirements of the database and the table and the relational database, how to establish and what are the requirements and how we can move with the advanced. So I hope this session is useful for you, and if you have any comments and suggestions, please drop it to the comment section and I will be there to respond. Please subscribe me if you haven't subscribed yet, and forward this to your friend circle and family and friends. I would love to grow with you in this channel, and I wanted to make sure that the each and every portion has been covered in each and every training. I'm gonna come back after this training, SQL Server training. I'm gonna come back to the other training, maybe Oracle, e-business, and many other trainings. So I want you to subscribe me to get notifications. So have a great day, take care, and stay tuned. Goodbye.